Right, so the fundamental theorem in calculus goes like this. We have an interval that goes from B to A. Now, it's extremely important that when we're talking about this, that it meets to certain conditions. And the conditions that we must have is we must have a closed interval from A to B, and f of x must be continuous. On that interval from A to B. If this is true, then this equals f of B minus f of A. Now, let's talk about the notation here, because the notation is really important. So what does this mean? What this means is that, so again, means it's the antiderivative. So that means that the derivative of f of x is equal to f of x. All right, now what do all of these terms mean? So let's go through and define some of them. So when we're talking about this, our limits of integration those are B and A. Now, our variable of integration is x. A couple more terms that we need to talk about. The f of x portion, lowercase, this is called the integrand. And over here, f of b and f of a, and I said that a little while before, both of these are the antiderivatives at a and b. Now, our shorthand notation that we do when we're talking about this, we can go ahead and say that this is the same thing. Now, one notation that we'll go ahead and see a lot is that the interval from B to A of f of x dx is equal to f of x evaluated from B to A. Now, again, the notation is saying this is the antiderivative, so f of x prime is equal to f of x. So this means I've already taken the integration, and now I go ahead and plug in and subtract b minus a. So as we said, this is an area function. So when we're talking about area, we are talking about the area as net area All right, so what can I use this? Let's go ahead and look at a really common trig function, just the integral of the sine of x. And I want to go from 2 pi all the way to 0. Well, if I look at this trig function, it has a range of 1 to -1. And we want to go ahead and take a look at what happens all the way to 2 pi. So I am going ahead and graph this, and my function will go like this. Now, I'm only interested in the area between 0 and 2 pi. So anywhere in the region where it's above the curve, it would be positive. Anywhere below the curve, it would be negative. So the net area of this is actually 0. Now, if we integrate it, what is the integral of the sine? Well, in order to do that, we need to recall that dx of the cosine of x is equal to minus the sine of x. So in order to make this match up, I would need a negative here to balance that out. I put a -1 on the outside, so I haven't really, in essence, changed anything. So derivative of minus the sine is the cosine. So to do this out mathematically, other than what we have in the geometric piece, that would give us -1 times negative sine of x dx as it goes from 2 pi to 0. So that is equal to -1. Integral of that is going to be minus the cosine of x evaluated from 2 pi to 0. So I'm going to go through and plug that in. So the minus cosine is positive cosine of 2 pi minus the cosine of 0 and the cosine of 2 pi